So for this lesson on K-maps, we're going to do a little bit of a mixture here. We're going to do a K-map, a 4-variable K-map, and then we're going to also talk about this exact example, use that with the Quinn-McCluskey simplification method. And so it's going to be a little messy here, trying to organize the papers, and hopefully you'll be able to see everything well enough. So let's start here. I have my expression here at the top. Now it might look scary because there's so many elements there. However, the more elements there are, that means the more ones we have representing our outputs. And the more ones we have in these spots, the larger we can group the ones. So we can group them in larger groups. That means we can express them with fewer min terms. So in this example, what we have is a 4x4 grid, and what I've done so far is I've just numbered each of the cells correctly. Now, just as with a 3-element or 3-input K-map, we need to make sure that when we do double variables, we put the 1, 1 in the third area. So here we've got 0, 1, 0, 0, 1, 1, 1, and then 1, 0. And we'll do the same on our rows. So 0, 0, 0, 1, 1, 1, 1, 0. So that makes our count look a little funny. So it's 0, 1, 2, 3, 4, 5, 6, 7. We skip this row. 8, 9, 10, 11, 12, 13, 14, 15. So now we can start, well, actually before we start putting in our values, I'd like to mark the columns. Let's name the columns. So here I have my AB on the left-hand side. This is showing our row variables. So when A is true, when A is 1, it's the last 2 rows here. I'm going to write A there. That's really hard to see, but maybe showing you the other ones will simplify that a little more. So then we have 1, 1 for B here in the center 2. So I will keep B there. Now we can start doing the columns. So we have C is equal to 1 in both of these. And we have D is equal to 1 in the 2 center columns here. Now let's start inputting our values. So we have a 1 in 0, a 1 in 1, a 1 in 2, a 1 in 3, a 1 in 5, a 1 in 7, a 1 in 8, 1 in 10, 1 in 14, and a 1 in 15. And just for simplicity, I could leave these blanks blank, but to make it more obvious that they're blank, I'm going to put zeros in them. So this looks very confusing. But this actually breaks down very nicely. So if we remember the fact that we could wrap around, we could group this one with this one, because we could wrap around in this row right here. But also, we can wrap around the other direction as well. So we could wrap this one with this one, and this one, and this one. So all four corners can be marked as a single minterm. So I'm going to use green to mark all four corners here. And the easiest way to mark the four corners is just to kind of give a wide sweeping outward mark like that. And of course, put our box for our legend. So now that that one's out of the way, let's look at our next large grouping we can do for ones. The next large grouping would be these four, 1, 2, 3, 4, together. So let's mark that. I'm going to use the light blue again this time. And in fact, I'm just going to actually color those to make those more obviously blue. That's actually looking fairly confusing, so I'm going to try to zoom in for you to get a better view of that. So this green is actually not as dark as I would like. It's really important to keep your colors different and keep all that separated so you can see what you're grouping. So I like to usually choose completely different colors, as contrasting as possible, to make that more obvious. Okay, and finally, we only have two ones left here at 14 and 15. So I'm going to use orange to color those two. So you can see I have green in each of the four corners, then I have orange for these two, and this big block in the middle I have blue. So if I zoom back out, there's my blue, even though it doesn't look quite blue. Yeah, that's a little better. And then I have my orange. So let's go ahead and try to group these. I'm sorry, not group them, but name them here. So for our four corner values, we have, we can look at rows or columns first. I usually prefer looking at the columns first. So if we look at the columns, we are only in this column and this column. And what we notice is that C changes. C is a 1 here, C is a 0 there. So we're not in the C column. And since we're in both of these columns, we can look down and notice that we are in what's called D naught, because it's not within the two D columns. So we are in D naught. And let's look for the rows now. So we have the rows that we are in are the top row and the bottom row. If we notice, A changes. So A doesn't have anything to do with this particular expression. So we have basically the A is a 1 here, a 0 there, so it cancels itself here. If we look at the B, we look here, we are not in B column at all. In fact, we are in what's called the B naught columns. So this is not B, this is not B, this is not D, this is not D. So the columns and rows that we are in, all that we need to write this expression is we are in B naught D naught. So let's move to the next one. The next one, we'll go with this large block in the middle. If we look at the columns first, we notice that we are clearly within the D columns, both of them. So that's good. We are clearly within D, which means if we're in both columns of D, we are not in both columns of C, because here C changes from a 1 to a 0, and so that cancels. So the only thing that's true here is D. And now let's look at the rows. We are very clearly defined in the A naught rows, both of them. So the expression for this would be A naught D. And finally, the orange here, we have a C column that we are clearly within. And as far as the rows go, we're actually clearly in 2 rows. We're in the A rows, but only the A row that overlaps with this B row. So the expression for this set of terms would be A, B, and C. So that is the simple way of doing Boolean expressions and simplification. As long as you do the absolute minimum and the most efficient, which means the largest groupings possible, that should get you to the smallest way to express your Boolean expressions. Something to note here is, notice the larger the number of ones we can group, the fewer inputs we have to use to define it. So here we have 2. We have to use 3 variables to define those 2 numbers. Here we have 4. We use 2 variables to denote those 4. If we had a single lone variable here, like a single lone output that we just could not group with anything else, that would require all 4 variables. And that's what, if we looked at any of these in particular, like this 1 right here by itself, this would be A, B naught, C naught, and D naught. So each one by themselves requires 4 variables. Here a grouping of 2 requires 3 variables. A grouping of 4 is 4 variables. And if we had these and these, then that would be, for instance, and if that were the case here, we would be clearly just within D. D would be all we would need to use to define those numbers. So the more ones we can group, the fewer inputs we need to represent those ones.